Hi, welcome to ClickMyProject.com.
Now we discuss about the topic of modified SVPWM algorithm for 3 level of VSI with synchronized and symmetrical waveform. Abstract: to generate a required reference vector then the triangle comparison in based of PWM technique. So the 3 level inverter space vector is a PWM strategy, is a contain broader choice of switching sequence. This space vector based in PWM technique involved in various steps. So these steps are computationally executive has been used in our control system. The center alignment of PWM is the most effective way for the MCU implementation because it can easily generate the center align of PWM. So the multi-level of generation, the signal space vector is a pulse width modulation. The inverter leg switching times are generated by this algorithm and the middle vector switching times are concentrate sample to interval. The adjacent voltage space vectors are forming the small triangular, it's called as sectors. So multi-level of converters can be meet and increasing a demand of power ratings and power quality associated with reduced harmonic distortion and lower electromagnetic interference. So to optimize the switching flow, we have to use the introduction in many industrial application of pulse width modulation. The voltage source will be PWM of VSI. So the speed induction motor drive have gained more importance in the field of the high performance. So drive the invention of the field oriented control broad renaissance. The induction motor is controlled by FOC algorithm. So the transformation reference frame contain the has complexities or new target is a control strategy and generate flux and current discrete space vector algorithm and ripples. The switching inverters or lookup tables and ripple further generate in SVPWM. So you have to pass the signal for input side of induction motor. It will be assigned and in the generated gating of pulse it will be used to TTC switching tables. This TTC switching tables you have to use a PWM algorithm. It's a simplified to achieve the algorithms normally. So these are the main function. So at the same time we have some existing. So existing is a multi-level topology have been used as a rectifier for the connection of renewable energy source to the utility of grid and as a power containing system in variable speed. So the combination of large number of semiconductor to achieve a high ratings well established, an arrangement where all individually controlled together in series. Voltage source multi-level inverter topology synthesis is a voltage waveform from several voltage level. So the 3 level of inverter is proposed. This method is based on the simplification of space vector. So 2 level of inverter it will be reduced. So 3 level of insulated gate bipolar transistor we have to use. Some disadvantages: it's also suffer from demerits of the analog circuit such as offset drifting and aging effect and low noise immunity. Main disadvantage: non-zero current error and steady state. In proposed system, this paper in novel space vector pulse width modulation we have to use, reducing switching loss and modulation scheme under the novel strategy, changing the switching states in single phase voltage at the same time. So the losses can be reduced in switch. At the same time, the DC bus voltage is efficiently generate less harmonic distortion at generating sinusoidal inverter. So the performance of the controllers methods total harmonic distortion voltage output is the inverter. So the objective of choice and modify analysis are first performed. Advantages. So the principal advantages SPPWM and SPWM is that enhance of DC bus utilization by about 15%. It is instructive to evaluate the sample average pole of the phase of VAO instance and understand. Basic system architecture. First you have to design the source. So design the source means you have to select the simulating model PWM and based on modular signal information it converted a space vector modulation, use the creation alternating current and voltage source inverter and DC line output converter. Finally you have to waveform analysis, signal generation of result analysis. Now we discuss about the model of modified SVPWM algorithm with VSI of synchronized and symmetrical waveform. So this circuit you have to use simulating library for the normal parameters value. You have to use a DC voltage and voltage measurement and current measurement, 3 phase of load and filter, 3 phase of VA measurement. It will be act as a filter and scope normal schematic power GUI, and then you have to use a mux transformation controller and IGBT diode, and sometimes you have to use a MOSFET diode also. Normal diodes and switching, you have to connect the gate of normal MOSFET diode. So the gate you have to all X1 X2 for the switch pulses. So the A B C it will be taken from the IGBT diode. Each and every 4, 4, 8 and 12 switches, it will be act as a B C of 3 input of voltage. That ABC it will be act as outages, and the outages you have to given a two kind of filter of the line to line voltage, phase to phase voltage, and controller of you have to use a PWM, SVPWM and PWM. So both controller it will be converted the matrix analyzing, and in matrix of you have to give the logic operation for the circuit also. So in the space vector you have separately added some space vector model in subsystem. That model also you have to design. First you have to save the model and run for the circuit. It will be run automatically. The outputs are displayed for the scope. The inputs how it will be passed, it will be filtering and analyzing. Finally you have got the output. So these are the basic model. So the model you have to analyze what is the signal, the parameters value how to given. So the range you have to given for related base paper work, and sometimes you have to given related take on the extra enhancement works also. So this is the basic model, this is the final output. So if you want to change the parameters means you got a different output from this all those things.